The first of the endocrine glands that we'll look at in more detail is going to be the pituitary gland. Now, the pituitary gland can also be known as the hypophysis. The hypophysis, or the pituitary gland, is going to have an anterior and a posterior side to it. The posterior pituitary, known as the neurohypophysis, is going to be having this neural fiber-based tissue. So it looks more like a nervous tissue setup. You also have these pituocytes. The pituocytes are going to be the cells found within this tissue as well. So you're looking from a histological point of view. The posterior pituitary, or the neurohypophysis, is going to have a neural or long fiber structure to it. And I'll show you that in a second. The other side, the other half, is the anterior pituitary. Now, the anterior pituitary, also known as the adenohypophysis, is more glandular tissue. So we have a mixture of anterior pituitary, which is glandular, and posterior pituitary, which is more neural. If we look at the actual histology here, we're going to notice that this right here is going to be the neurohypophysis, or the posterior pituitary. You'll notice that you have more of these lines, more of these strings. Those are the neural fibers. Where on the other side is more glandular tissue. This is more of the adenohypophysis, or the anterior pituitary. So you're looking at the posterior pituitary, neurohypophysis, and the anterior pituitary, the adenohypophysis. But if you look at this other diagram over here, you'll see the nerve fibers are running straight down from the hypothalamus right into the posterior pituitary. It's trying to show or symbolize the direct connection of the neural fibers from the brain down into the posterior pituitary. But in contrast, this section right here, which is the anterior pituitary, you're seeing all the glandular tissue. It doesn't have a direct link of the nervous fibers like the posterior pituitary does. Instead, it's getting its signals via the blood vessels that are coming down. You can notice this whole entire network of blood vessels. And that reaches much further up into the hypothalamus as well. So the anterior pituitary, posterior pituitary, both are in the same gland, but really it's like having two separate glands in one. So here's a little look at the pathway here. Now notice you have ADH released. That's going to be your antidiuretic hormone. That is produced in the hypothalamus. Hopefully that rings a bell back from when we looked at the nervous system. And that then is produced in the hypothalamus, but sent down into the posterior pituitary. So we have a similar thing happening for another hormone as well. Over here, you're seeing OT, that's oxytocin. Remember, oxytocin is also produced by the hypothalamus. It's then sent down into the posterior pituitary again for storage and release. So we have these two hormones that we originally discussed back in the nervous system. We're now talking about them for the endocrine system. Remember, we're trying to tie things in, bring things together. So this is a nervous and endocrine link right here. While the anterior pituitary, we'll get to that one later. Let's focus on the posterior pituitary. So oxytocin, maybe you might remember from the nervous chapter some ideas of what this does. But this, one of the main things, is stimulating uterine contractions. So it's stimulating uterine contractions, which is happening because of the increase in calcium. So when a woman's going into contractions for labor, that calcium levels are increasing. Now go back to the muscles. More calcium means it has more of the actual fibers contracting, making a stronger contraction. So we have oxytocin dealing with uterine contractions for one function. It also, after birth, helps with the triggering of what's known as the letdown reflex. That's when the milk is being basically produced and let down into the actual glands. So again, oxytocin. You're saying, oh, this is all female. Do males have oxytocin? Yes, males also have oxytocin. While the role of oxytocin is more well-defined and more well-known in females, there is also oxytocin in males. It's not as well-known what it was doing, but the current research are saying it's looking into more of a sexual arousal and the sexual process in both females and in males. So the idea of oxytocin. Antidiuretic hormone, known as ADH. Now, the antidiuretic hormone is going to help with controlling fluid balance in your body. So we'll start off with if the solute concentration is high. That means in your blood, you have a higher than normal level of solutes or particles. Because remember, your blood is mostly water. So we're monitoring how much solute there is in the blood, as well as then what's in the forming urine. If the solute concentration is high, you're going to have these osmoreceptors. They're sensing, they're feeling and understanding what the levels of solute are. They'll transmit to the hypothalamus, so up to those hypothalamic neurons. They will then tell those hypothalamic neurons that ADH needs to be synthesized and released. Because ADH is antidiuretic hormone. Remember, diuretic, fluid leaves. Antidiuretic, you're trying to conserve fluid. So if we're thinking about this one, we're going to inhibit more urine formation, trying to conserve fluid and result in more concentrated urine. Saying, well, hold on, why? If your solute concentration is high in your blood, by conserving more water, it helps to dilute that blood, lowering the solute concentrations back down to homeostatic levels. Now, we'll get into all this a lot more in the urinary chapter, but for now, know that antidiuretic hormone, if produced and released, helps to conserve water, keep fluid in the body, therefore creating more concentrated urine and not letting fluid leave as easily. But on the flip side, concentration is low for solutes. Well, if your concentration is low, that means you have plenty of fluid intake. In this case, antidiuretic hormone is not released. It's not released because you want to flush water out. You have plenty of fluid in your body. Your solute concentration is low. You want to try to bring it up a little bit to where your homeostatic levels are. And this is a give and take throughout the day. You'll have higher concentrations of solute, you have lower concentrations of solute. All depends on your fluid intake. So ADH is trying to help regulate that and maintain a balance. Now, the consumption of alcohol will cause a problem with ADH. What happens is alcohol inhibits ADH, basically prevents ADH. So by preventing antidiuretic hormone, no matter what your solute concentration is, it'll increase fluid expulsion. Because you're not conserving it, you're not trying to hold water in. So even if your solute concentration is high, you're still having an increased amount of fluid being released from your body. And that's one of the reasons why if you drink a lot in the evening, next morning you might have a hangover. That hangover in part is because your fluid levels are off in your body. Your concentration of solutes are too high. You typically don't have enough water in your system. That's why trying to prevent that hangover for drinking, have some water with it. By having some water with the alcohol, it helps to make sure you're trying to maintain fluid levels as much as possible. But if nothing else, make sure you have some fluid the next day. Help to regain those fluid levels and bring them back up to homeostatic balances. All right, posterior pituitary stores and secretes antidiuretic hormone and oxytocin. But remember, we pointed out that the hypothalamus is what produces antidiuretic hormone and oxytocin. The posterior pituitary does not produce those two hormones. It's the oddball. It's the only one of the glands that doesn't produce the hormones it releases.